A lot of times mid-conversation it'll come out that I'm an engineer, and I'll normally get some kind of some kind of response from somebody to the effect of, "Oh, you're an engineer. You must be smart." And I say, "No, no, no. I'm not. I'm not that smart. I'm just stubborn as hell." I took differential equations 6 times if you count the times that I dropped it. Then they'll normally come back with something like, I couldn't do that. I don't even know what differential equations are. I'm not a math person. That's not true. Stop telling yourself that. I'm not a math person either. I don't believe in math people per se. I think any of us can do most things pretty well, especially with something that looks complicated like math. You just take the complicated, big, scary math and you break it into smaller and smaller and smaller pieces until you have a piece that's easy to digest. If you can add, if you can subtract, then you can do differential equations and most higher math. So to answer the question, what are differential equations? And if you're taking the differential equations class, I'll go ahead and tell you how to get an acceptable grade. I was going to say A, but some teachers, they just shoot you down and make it so hard. It's ridiculous. And I'm sure I'll get crucified by a lot of the math types that'll say something like, you did a crap job of explaining it. Well, the grad students and other people that were teaching in the math department did an even worse job explaining it to me. So here we are. I got a couple of notes on my board to walk through, help me through my thoughts. Dank math. First of all, differential equations has a wide range of applications. It's pretty cool. So what is differential equations? Well, differential means change. So you can think of differential equations as just change equations. Now, they normally relate how one thing changes to how another thing changes. So for example, I'm walking, and as I'm walking, my position is changing, and as I'm walking, the time is also changing. So you can write an equation that relates the change in my position to the change in time, and that's a differential equation. That's really all there is to it. Equations that relate the rate of change to changes of other things. So anything that moves, anything, flow rates, circuits. So what's the value in this? If you have an equation that relates my position to time, then you can predict where I'm going to be at in the future. And if you can predict it, then you can change it. So then you get into controls, system dynamics and controls, a bunch of really cool things you can do with differential equations. That's not just theoretical math or when will I ever need that. So that's the 1,000-foot overview of what differential equations are. And if that answers your question and that's all you wanted to know, get out of here. We're going to dive a little deeper to it and talk about how you might do well in a differential equations course if you plan on taking one. So going into differential equations, you're going to want to make sure you brush up on the things that are relevant to differential equations. Quick vocab, variables, functions, integrals, and derivatives. Brush up on those ideas. You're going to want to be well versed going into this class. There's a few key realizations that you need to make early on, and if you struggle with these, you're going to get set really far back. Differential means change, and in math language there's a couple of ways to denote this. The first way is to write a triangle, which is Greek, letter delta. Anytime you see that triangle, that means change. You have a variable, let's say x, and you put a little d in front of that x, you have dx. All that means is change of x is simple. So we went over, functions. All right. In differential equations, you'll have how things change through time, and then they like to say with respect to. That just means, through time, with respect to time. There's a few types of differential equations. The ordinary differential equation is the first one that comes to mind, so I'm going to run through that one real quick. You got an ordinary differential equation. It's written like this, and then equals something on that side. Delta, change, change in x over change in time, and then this dx over dt means the exact same thing. In math, looking back, you have all the different ways of saying the same thing. subtraction or taking the difference. Well, taking the difference and subtraction gives you your differential, i.e. differential equation. So back to the practical applications, or how will I use this in the future. We go back to position and we have a number line. So if your position equals x, well, that's a pretty easy algebraic equation. You plug your number in there and you get an answer. If you take the derivative of your position, you get a differential equation. So a lot of people think in differential equations that you're always looking for a number, and that's not the case. A lot of times your answer will be just the equation that relates one thing to another. So to illustrate the change, the differential, you'll relate position to time when you take the derivative of that. So you get little d, change in position, over change in time. Now you can think of change as final minus initial. Integrals have limits, you kind of ties all together. So final position minus initial position over final time minus initial time. That gives you a change over a change, and that gives you velocity. Change in position with respect to change in time, that's velocity. So to help it make sense in my mind, I always like to add some kind of units. That's not really practical in the math department type books, but position is in meters. Velocity is in meters per second. That per second means it's a quantity related to another quantity, and if those two quantities are changing, you can write a differential equation that relates the two. Now, another important realization in differential equations in calculus in general is that derivatives and integrals stack on each other. You can go to infinity. You can take the first derivative, the second derivative, all the way to like a 50th order differential equation, which if you're in engineering, you might actually wind up simulating in some fun program like MATLAB, thanks to your differential equations. So position, the first derivative, is velocity. The second derivative is acceleration. And acceleration, what is that? How the change in velocity relates to the change in time, i.e. meters per second squared. Ooh, that's a good one. And then, you look at how it breaks down, and it's the same thing. Change in velocity over change in time, final velocity minus initial over final time minus initial. You get the idea. So this is a great exercise to work through to get a feel for what differential equations are, how brush up on your derivative skills, go the opposite direction and brush up on your integration. You can kind of see how things flow and relate to each other. And if you start at position and you do all of your derivatives, congratulations, you've just created the kinematic equations. That's pretty awesome. Now, how do you do well in a differential equations course? It's a challenge. It is a challenge. Be stubborn as hell. Do not give up. Put in the work. Put in the effort. Read the book before the lecture. Even go as far as to try a couple of example problems. This won't necessarily make it any easier to understand, but it'll make it a lot less complicated once you get into that classroom environment. Another thing you can do is be resourceful. There are tons of great online resources and courses. Khan Academy is the first one that comes to mind. If you don't read the book before the lecture and be resourceful and learn how to teach yourself, because I know you're paying for a class, and the teachers, they mill you through like cattle. It's a big money-making machine. You got to look out for yourself. Watch all the Khan Academy videos. If you do those two things, you have a pretty high rate of success. If you don't do those two things, then you really have no business bitching about it if you don't do well in the class. So that's my advice. And even doing that, because watching all of the Khan Academy videos, reading 2 books side by side ahead of the lectures, I still had to take it a couple of times before I got through the course. But you can do it. Don't give up. Don't believe the lies that you're not a math person. Anybody can be a math person if they break it down into parts small enough to digest. If you can add, if you can subtract, you can do it.